Okay, we're going to go over the homework. Quiet, please. Galen. Galen, move now. Okay? We're going to go over the homework and then roll right into the lesson. If you remember last time we were doing, what is it? How do you simplify and you raise something to the 0 power? What does that always equal? 1, not 0. Right? So this is okay, 1. How do you simplify when you have a negative exponent? What do you do to get rid of the negative? Blank. Right? You flip it to the other side of the fraction. So you already had a 3 there, now you've got a 3 to the 4th. Okay, now what can we do with that? 3 to the 1st times 3 to the 4th is 3 to the 5th. Okay, this is supposed to be to the negative 2, to the negative 3. 5 to the negative 3. Again, how do you simplify a negative exponent? You flip it. 1 over 5 to the 3rd. Right. 1 over, it's actually negative 7 squared. Right, so those are properties. Raising to the 0 power, negative exponents. Right. The next page was, again, what do you do when you're multiplying numbers that are raised to powers, and the numbers, the base, what you would call the base, right, are the same. Right? Same base. Right? What do you do with the exponents? You add them up, right? So in this case, it would be 10 to the 4 plus 4 plus 2. 10 to the 10th. How about this one? 9 to the what power? That's a negative 8. 2 plus negative 8 plus 6. It should have been to the 0, which means by the property on the other side, 1. Okay, I didn't notice that it had errored like that. So those are the properties we did so far. Now we've got some others. What do you do when how do you simplify when you're raising something to a power and then you have parentheses and you're raising that to a power? What do you do to simplify the exponents? You multiply. Right? So 5 to the 4th squared is 5 to the 4 times 2, which is 5 to the 8. Right? M to the 3rd to the 5th is m to the 3 times 5, m to the 15th. So what would be p to the 5th to the 4th? P to the 5 times 4. Right? P to the 4th to the 5th. The same thing, right? It doesn't matter the order you multiply, you would get the same thing. P to the 20th. How about P to the negative 5th to the 4th? P to the negative 20. But then we wouldn't leave a negative exponent. How would we simplify to get rid of the negative exponent? Flip it. It's 1 over P to the 20. Okay, now we've got some more variable expressions, right? X to the 6th to the negative 4th would be, just simplify this part of it right there. What is X to the 6th to the negative 4th? Multiply. Negative 24. So now it's X squared times X to the negative 24. What do you do with the exponents? Right, you add them up, right? At that point, it's multiplying the same base raised to different powers, so that's x to the negative 22. Okay, but now you've got a negative exponent, so you flip it. 1 over x to the positive 22. Right? Again, how would this one work? The w to the negative 2, that stays. X to the w to the 7th to the 3rd is 21. Okay, and then same base, both have exponents, add these up. That's w to the 19th. Okay, what about r to the negative 5th to the negative 2? What do you do with those two? What do you get when you do it? Positive 10. So now it's r to the 10th times r to the 3rd, which is to the 13th. Okay. So now what's different about this property? Okay. Because I mean, this first one, x to the negative 2 squared, we're going to do what we did on the last slide, right? What's the operation between those two? So multiply. So that's x to the negative 4th. But what's different here is that you've got more than one factor inside parentheses. So you're raising everything inside to the 4th power. So you've got to take a step and show that. Right? This is 3 to the 4th times x to the 4th times y to the 5th to the 4th. Right? So this is, what can you do with this x to the negative 4th and x to the positive 4? It's going to be x to the 0, which is 1. Okay, what is 3 to the 4th? That would be 3 times 3 times 3 times 3. 3 times 3 is 9, so that's 9 times 9. It's 81, right? And y to the 5th to the 4th is? Okay. Again, when you've got the powers outside parentheses, you've got to bring it in on everything inside the parentheses. 3 to the 4th, c to the 5th to the 4th. And c squared to the 3rd power is c to the 6th. So 3 to the 4th, we just did that on the last, that was 81. This is c to the 20 and c to the 6th. One last step, how many c's is that? 26. Okay, now both sets of parentheses have more than one factor inside. So we need to take this 6 to the 3rd, a to the 3rd, b to the 3rd, and 5 squared, a to the negative 3 squared. Right? Then simplify what we can. What's 6 times 6 times 6? Right, that would be 36 times 6. $216. So 216, a to the 3rd, b to the 3rd times 25 times a to the negative 6. Okay, now we're going to have to do a real long multiplication. 25 times 216. Right, 5 times 6 is 30. 5 times 1 is 5, 8. 5 times 2 is 10. 2 times 6 is 12. 2 times 1 is 2, 3. 2 times 2 is 4. Does it look right? 5,400. So this is 5,400. What's a to the 3rd times a to the negative 6? A to the negative 3, which needs to be flipped. And b to the 3rd. Marcus. Unless you want to stay after. That'll work, right? Got to take that test anyways. No. Okay, now we're dividing, right? When you divide this same base raised to different powers, right, then you subtract. So 2 to the 6 divided by 2 squared is 2 to the 6 minus 2, 2 to the 4th, right? So when you multiply, you add. When you divide, you subtract. So what would be y to the 5th over y to the 4th? That would be y to the 5 minus 4, which is y. How about d to the 3rd divided by d to the 9th? 3 minus 9. Okay. If you make it d to the negative 6, then what do you have to do? You have to flip it. Normally, if you see that you've got the highest powers in the denominator, then just do the subtraction from there. 9 minus 3 is 6, and then you put it in the denominator. In either case, it's 1 over d to the 6. Right? Okay, k to the 6th over k. How many k's is that? 6 minus 1, 5. And j squared over j to the 5th. How many j's, positive j's, are going to be where? Right, it's going to be j to the 5 minus 2 in the denominator. Okay, a to the negative 3 over a to the 5th. Should I subtract negative 3 minus 5, or should I do 5 minus negative 3? Which one gives me positive? And 5 minus negative 3 is 8. So that's a to the 8th in the denominator. And b to the 7th over b squared. Subtract 7 minus 2, b to the 5th. X to the 4th over x to the 4th. What do you get if you subtract? You would get x to the 0, which is 1. And normally when you see the same factor in the numerator and denominator, you're just going to cancel it out anyways, right? It's 1. Anything divided by itself is 1. Okay, now, y to the negative 1 over y to the negative 5. Should I subtract negative 1 minus negative 5 or negative 5 minus negative 1? Which is positive? The negative 1 minus negative 5, which is like negative 1 plus 5, which is 4. And z to the 8th divided by z. That would be z to the 8 minus 1, 7. Okay, now we can also have a divide going on inside parentheses and then a power outside of that. Just like with the multiplication, and it works the same way. Right? You're going to bring in that power on everything that's inside the parentheses. So in this one here, 4 over x to the 3rd squared, right? That would be 4 squared x to the 3rd squared. 16 over, what is x to the 3rd squared? X to the 6th. Okay, do the same thing with that. If I bring in the negative 2 as an exponent, it's going to look like a to the negative 2, 5 to the negative 2, b to the negative 2. And then what do you have to do with every one of those? Because they got negative exponents. You would have to flip them. Normally, if you have this, a over a fraction raised to the negative 2, then if you flip the fraction, right, 5b divided by a squared. And now you don't have to deal with the negative exponents. Just flip this, and it's positive. So that is 5 squared b squared over a squared. 25 b squared over a squared. homework.